All right, we're at CES today talking about the modern mobility and the future of mobility, and what we're demonstrating today is how we can use virtual reality technology to help engineers, manufacturing engineers, product engineers, service and maintenance engineers identify the product design issues that might come up as they're trying to design the future of mobility. In this case, I'm looking at a hybrid vehicle, the plug-in hybrid vehicle with a EV battery going into the back of it. I have this battery right here that is mounted to this rather complicated mechanism that is used to help human operators put the battery into the back of the car safely. Now, what I do is I'm going to be in VR experiencing what this production environment would be like if I actually went ahead and invested all the time and the money and the effort that it takes to build this vehicle in reality. And rather than investing all that money and finding out unexpected production issues, I want to find that out as early as possible, and that's what we're using VR for today. So what I want to be able to do is I want to be able to drive this battery into the back of the car. First things that I'm noticing is I'm just getting a feel for, is this a comfortable, safe, accessible way for me to put this battery into the back of the car? So far it doesn't feel so uncomfortable. It seems pretty natural for me to grab onto it. But as I start bringing the battery toward the trunk, now here's a problem. I can't see the entirety of the opening in the back of the car where this battery needs to go. And that could cause some problems because if I can't see where I'm going, you can see these little red arrows popping up in my field of view, and that indicates to me that somewhere in that blind spot there is a collision between the battery and the car itself. And you can see, even though I'm trying to move my hands further, the battery in the VR simulation just stops moving. And we're doing all of these calculations for the collisions, the interactions between the product designs and the vehicle itself in real time, simulating what would probably happen if I'd gone to production with this. So this is a very important thing for me to be able to discover as early as possible in my manufacturing planning and in my product planning, that this is a not quite ideal manufacturing environment for me to be inserting that battery into the back of the car. Over here we can see another sub-assembly operation where I am taking the individual battery modules off of a logistics tray like this, picking them up with this ergo assist arm, and I want to load the batteries into this battery enclosure that ultimately will go into that car that we see over to my left. So again, first thing is just that gut level feel of, is this a comfortable, natural working position to have my arms here at this elevation? This feels kind of artificially high for me, but maybe that's because I'm a relatively short assembly operator. And we can see that this gives me the ability to guide the battery into this battery enclosure. Now the problem that is potentially addressable or identifiable in this scenario is the fact that this arm does not seem like it's capable of reaching this farthest position here, maybe even the next two positions next to it. And that could be an issue for us in a typical conveyor-based or chain pull kind of assembly operation. The good news is that we're proposing that this is going to be on an automated guided vehicle. This AGV could potentially translate a couple battery slots over, and that would give me the ability to reach that. Now, if this wasn't really planned to have an AGV, if this would arise in the manufacturing environment, this would be a very expensive issue to discover at the last minute. And these are the kind of things that we're trying to identify by using VR and addressing the future of mobility.